Good day, everyone. Today we shall be looking at some questions from IJMB 2016. All right. Question 1 says, calculate the number of moles of copper formed when 20.50 grams of copper 2 oxide completely react with hydrogen gas. Before we do that, we need to write equation of reaction, meaning copper 2 oxide, which is CuO plus hydrogen will give copper and water. All right. Equation is balanced. So we have the mass of copper 2 oxide has been given to be 20.50 grams. Now we said calculate the number of moles of copper. Of course, from this equation, we have 1 mole of copper produces 1 mole of copper 2 oxide gives rise to 1 mole of copper. So the same number of mole of copper 2 oxide will be equivalent to the number of mole of copper. So in this way, number of mole can be calculated as number of mole equals mass over molar mass. All right, the mass has been given to us as 20.5, while the molar mass of copper, copper is 64, oxygen is 16. So everything is 80 grams. So over 80. Number of mole, therefore, 20 divide, use our calculator, 20.5 divided by 80 gives us 0.25. 0.256 moles. Answer. That is question 1. Now, question 2 says, question 2a says, define molecular ion. Molecular ion can also be taken as radicals. Another name for molecular ions are called radicals. Radicals or molecular ions are a group of atoms called polyatomic that carries a charge. For instance, we have ammonium ion, carbon, CO3, 2 minus, that's carbonate, 4, then SO4, 2 minus, sulfate 6. So these are examples of molecular ion. They are a group of atoms called polyatomic carrying a charge. This is a positive charge. So these are ammonium ion, carbonate 4, sulfate 6. Now, 2b says, how many atoms are there in a 3 moles of cobalt? 3 moles of cobalt. Sorry. All right, question 2b says, how many atoms are there in 3 moles of cobalt? Of course, cobalt. 1 mole of cobalt contains about 6.02 times 10 raised to power 23 atoms, according to Avogadro's constant. That is 1 mole of any substance. So cobalt being a substance contains this. So 3 moles of cobalt, of course, will give, therefore, 3 moles of cobalt contains X, say X, atoms. So cross multiply, X gives you 6.02 times 10 raised to power 23 times 3, which will give us 18. This times this, 18.9, 18.18. This time this gives us 6. 0.6 times 10 raised to power 23. Answer. All right. How many grams are there in 90 grams of water molecule? Of course, 90 gram water molecule is given as CH2O, which contains the same Avogadro's constant, which is 6.02 times 10 raised to the power 23. This time around, it becomes molecules. And don't forget, a molecule of water contains 3 atoms here. So 2 atoms of hydrogen plus 1 atom of oxygen. But for us to find the number of mole, we have to number of moles equals mass over molar mass of water. So the mass given is 90 divided by molar mass of water, which is 1 times 2 plus 16, which is 18, is given as, somebody help us with the calculator. Molar mass of water, 90 divided by 18. Okay, this gives us 5. This is 5 moles. Therefore, so if 1 mole contains 6.02 times 10 raised to the power, therefore x, since 1 mole contains 6.02 times 10 raised to the power 23 molecules, therefore 5 moles of water will contain 5 times 6.02 times 10 raised to the power 23 molecules, which is equivalent to, multiply this by this will give us 30.1.10 times 10 raised to the power 23 molecule. We are not done yet because we are looking at atoms. And from this, since 1 molecule of water contains 3 atoms of H2O, therefore number of atoms equals 30.1 times 10 raised to the power 23 times 3 atoms. So in this case, we have this time this is 90.3 times 10 raised to the power 23 atoms. Question 2b. 2b3 says 10 grams of carbon. How many atoms are there in 10 grams of carbon? The same way, 1 carbon contains elementary particle, which is 6.02 times 10 raised to the power 23. Carbon has the relative atomic mass to be 12. Therefore, number of mole of carbon equals mass over relative atomic mass. Which is 10 over 12. 10 over 12 will give us somebody help us with the calculator. 10 divided by 12. 0.83. 0.83 moles. So if 1 mole of carbon contains 6.02 times 10 raised to the power 23 atoms, therefore 0.83 moles will contain, say, Y atom. So Y therefore equals 6.02 times 10 raised to power 23. So somebody help us with that. Times 6.02 that gives us 5.017 times 10 raised to power 23 atoms. Correct. Question 3 says, state the type of force between the structural unit of each of the following. A, diamond. Of course, diamond is a covalent bond, you know. Diamond is made up of carbon bond covalently joined together to form a hexagonal shape of carbon. So there is a covalent bond. Covalent bond actually occur here. Now, neon is a gas. The type of bond between neon molecule is covalent bond, also covalent bond. Then C, calcium chloride. Don't forget, calcium is a metal. So the type of bond between calcium and chloride is ionic or electrovalent bond. Then iron, D. Iron, of course, is metallic bond. Then E, carbon 4 oxide. Carbon 4 oxide is covalent bond. These are the type of bond in the following elements. When calcium reacts with a gas A compound B is formed. The compound B reacts with water to form a gas which turns red litmus paper. All right. We can get our clue from here. From the last one, it says a gas C which turns red litmus paper blue. The only gas that can turn red litmus paper blue in the laboratory is ammonia. So, identify A and B. Write the equation for the reaction of calcium with A, then B with water. Now, this question says I should identify A and B. Number one, calcium reacts with a gas and a compound B is formed. The compound B reacts with water to form a gas C, which turns red litmus paper. For us to identify A is, this is calcium plus nitrogen. This will give calcium nitrite. This is valency of calcium is 2, valency of this is 3, so N2. So this is gas A. Okay? Yes. B reacts with water to form, this is B, of course. B reacts with water, calcium nitrite with water. Gives us ammonia will be formed from here. According to the ammonia is NH3 plus calcium hydroxide. All right. Now, for us to identify A and B, A is nitrogen gas, while B is calcium nitrite. Calcium nitrite. So we've solved A. Then B, write equation for the reaction between calcium and A. This is equation between calcium and A. This is B. Calcium nitrite. Then the reaction between B with water. This is B with water. Ammonium is a verb here. So this is the equation. Question 5. Suggest one reason why boron ion are rare, but aluminium ion are common in compound formation. Of course, boron is less reactive compared to aluminium. Aluminium will react with material element that comes in contact with them. So no wonder we have several elements containing aluminium because of their reactivities. Boron is less reactive than aluminium. So you expect aluminium to be contained in most of these compounds. Number B, it said give the names and chemical formula of two important ore of aluminium. We have two basic aluminium ore. Number one, we have what is called bauxite. Bauxite is aluminium oxide hydrate. 3.2 water. This is bauxite, or otherwise known as aluminium oxide hydrate. Then 2, we call it cryolite. Cryolite. Cryolite has the formula Na2, Na3, AlF6. It is called sodium aluminum fluoride. Sodium aluminum fluoride. So these are the two basic ore of aluminium and their chemical formula. Question 6. In a vector Mayer experiment, 0.52 gram of an organic liquid of molar mass 120 gram per mole was vaporized at temperature of 298 Kelvin and pressure of 1.013 times 10 raised to power 5 Newton meter. Calculate the volume in cm³ of the air displaced, given that saturated vapor pressure of water at 298 Kelvin equals 2.32 times 10 raised to power 3 Newton meter. So we have our parameter listed. First of all, we have to identify all our parameters. In this question, we are given the mass of the substance, that is vaporized as 0.5. Mass of the substance is given as 0.52 gram. Then the molar mass is 120. Molar mass of that same substance. They didn't identify the thing, so 120. From here, we can all easily find the number of mole of this substance, because number of mole is mass times mass all over molar mass. So therefore, number of mole of this substance, number of mole, equals 0.52 all over 120. So that gives us, somebody can help us with the calculator, 0.52 divided by 120. This gives us 0.004 mole. So this is the number of mole of the unknown substance. Having identified the number of mole of the unknown substance, mind you, we are asked to find the volume from the equation. Volume, then we've been given temperature, then we've been given pressure. But there's an equation called ideal gas equation that shows the relationship between volume, temperature, pressure, and the number of mole, which is PV equals nRT. So making V the subject of the formula, we have P equals nRT over P. Sorry, V the subject of the formula over P. Now, N is the number of mole, which is 0.5, 0.04 times R. R is called the ideal gas constant, and it has a value like you've been given above to be 8.314. Then temperature has been given to you as 298 Kelvin. 298, 298 all over pressure. Now, this is the issue. We've been given pressure. Don't forget, we have the vapor pressure of the water. The saturated vapor pressure of water has been given to be 2.3. How do we determine the actual pressure? The actual pressure of the liquid is pressure of the liquid equals total pressure minus saturated vapor pressure of water. So the total pressure here has been given to be what? 1.013 times 10 raised to power 5 minus 2.32 times 10 raised to power 20 power 3. So the actual pressure of the liquid will be total pressure minus saturated vapor pressure of water, which will give us 9.8 times 10 raised to power 4 Newton meter. So in this case, we now substitute this with P. So this becomes 9.8 times 10 raised to power 4. Dividing this by the pressure gives us 1.1 times 10 raised to power minus 4 dm cube. Now, to convert this, our answer is to be converted to cm cube. So we multiply this times 1000. Therefore, 1.01 times 10 raised to power minus 4 times 1000 cm cube, which move this to be 1.01 times 10 raised to power minus 1. So multiplying this will give us, so converting this automatically give us 0.101 cm cube. Answer. All right, question 7 says predict the sign of entropy. This is entropy change for each of the following reaction. Of course, entropy is the degree of disorderliness of a substance. We have A, calcium carbonate, which is solid, and calcium, of course, there's nothing like calcium, but let's take it. This is calcium carbonate, breaks down to give us CaCO plus carbonate, plus carbon 4 oxide rather. So this is solid, this is another solid, and this is a gas. Of course, you know that entropy is positive. The degree of disorderliness is positive because you have more of the substance from the solid to gaseous state. So automatically we have entropy change to be what? Positive for this reaction. Now, reaction 2, question 2, B says carbon disulfide changes from liquid to gas. Of course, from liquid to gas, you have the molecules, bonded together here. But in the case of here, the molecules are more scattered. They occupy a number of volume compared to this, because this in liquid state, calcium sulfide is bonded together. The degree of movement is less compared to this one. So for this case, when it moves from liquid to gaseous state, entropy change is positive. Entropy change is what? Positive. The degree of the disorderliness is more. For question 7C, this is mercury in liquid form reacting with oxygen in gaseous form to form a solid. You can see, from gaseous to solid. What do you expect? The degree of movement of molecule is reduced. So entropy change here is negative. So for this case, C, entropy change is negative. Now let's look at the next one, D. D is sodium oxide in gaseous state and reacting with water in liquid state now form aqueous solution of sodium hydroxide followed by oxygen in gaseous state. So you expect the degree of movement of this molecule to increase in the gaseous state. You know, this is entropy in liquid state. This is water in liquid state reacting with this in gaseous state to give you aqueous state of ammonia and gaseous state of oxygen. So of course, entropy change here is reduced because this is in an aqueous solution. It's solid in the aqueous solution. So automatically we have entropy change here to be negative in D. Now let's look at the last question, E. It says, this is carbon monoxide in gaseous state reacting with steam in gaseous state. Steam in gaseous state, you know, gas now gives you carbon 4 oxide and hydrogen gas. They are both in gaseous state. So the entropy change is constant. There is a net movement of molecules is at equilibrium. The gaseous, since they are all in gaseous state, the entropy change is 0. There's no change at all in this case. So question 8 says, given that a certain gas is sealed up in a container, you have a gas contained in a container, what happened to the average speed of the gas particle as the temperature decreases? This brings us to gas states, law, Charles' law, and Boyle's law. Remember, Boyle's law states that the volume of a given mass of gas is inversely proportional to its pressure. That is Boyle's law, don't forget. Then Charles' law says the volume of a given mass of gas is directly proportional to its absolute temperature. This is Charles' law. Remember this. Now, he said, what happened to the average speed of the gas particle as the temperature decreases? Of course, when you decrease temperature, the volume reduces, you know, because volume is directly proportional to what? Temperature. Decrease in temperature, decrease in the volume of particles, speed of the particles that moves in the container. Number B, he said, B says, why does the pressure of a fixed volume of the gas decreases with decrease in temperature? You know, why does the pressure of a fixed volume of gas decreases? Why does the pressure of a fixed volume of gas decreases with decrease in temperature? You know, if you decrease the temperature, of course, the volume will decrease because they obeyed Boyle's law. They are ideal gas law. So they obeyed Charles' law. So they are simply because they are ideal gas law. They have to obey the gas equation, which is Charles' law. Number C. What happened to the pressure of an ideal gas if at the same temperature its volume is double? You know, what happened? And you know, ideal gas law, according to Boyle's law, says that the volume of a given mass of gas is inversely, because when we say inverse, the more the volume, the less the pressure. So in this case now, they say what happened to the pressure of an ideal gas if at the same temperature its volume is double? If you double the volume, it means the pressure will be half. You can see, if you double the temperature, since volume is inversely proportional to the pressure, doubling the volume is synonymous, it means that the pressure has been halved. All right. The next question is question 9. Yes. Question 9 says, Consider the following element in the second period of the periodic table. We have this following element in the second period. They are all in the second period, period 2. In the periodic table, we have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Which of these elements has the highest melting point? Of course, the element that has the highest melting point is going to be lithium, because lithium has the largest ionic radius in this case. So lithium has the highest melting point. Of course, it's a metal. While as you move down from the left to the right, you are coming down to what? Non-metals. So lithium will have the highest melting point because it's a metal. Number B, which is the most electronegative? Which of these elements in period 2 is the most? Of course, it's going to be fluoride. Fluoride ion, or fluorine. Fluorine is the most electronegative in this group. Number C, which of these elements can form cation? When we say cations are positive ion. Cations, they are positive charge ion. So of this, we have lithium and beryllium, because they are metals. So lithium will form Li plus, that is lithium with one charge, positive charge, and beryllium, 2 charges. So lithium and beryllium will form the cations. They are positively charged elements in this group. Then the last one says, which of these exists as monoatomic molecule at room temperature? When we say monoatomic means only one atom, and it's a molecule. Of course, it's going to be a gas at room temperature. So can we see it again? The element that will be a monoatomic at room temperature from that series is going to be neon, because neon is a noble gas. Neon. And the symbol is Ne. It's a monoatomic at room temperature. Unlike fluorine, oxygen, nitrogen that combines covalently to form a molecule, neon will form monoatomic at room temperature because it has a completely covered outermost shell. It has a completely filled outermost shell. So it's going to be a monoatomic element at room temperature. Question 10. This is going to be the last question on this section. Calculate the oxidation number of chlorine in ClO3. ClO3 minus. Of course, to get the oxidation number, let's make chloride the oxidation number to be X. So we equate everything to be minus 1. Now, sum this, it gives you X plus oxidation number of oxygen minus 2 times 3 equals minus 1. So in this case, X minus 6 equals minus 1. Therefore, X is going to be 6 minus 1, which is going to be 5. So the oxidation number of chlorine in ClO3 is 5. So that's why it is called chlorate 5. Number B, chlorine in ClO minus. That's number 2. ClO minus. The oxidation number X again, equate it to 0. No, minus 1. So add the oxidation number together, X plus minus 2 times 1 equals minus 1. X minus 2 equals minus 1. X equals 2 minus 1. X equals 1. So oxidation number of chlorine in this is 1. Question 10C. ClO4 minus. So the oxidation number of chlorine in this ion, the same thing. Let's say the oxidation number of chloride is X. This is minus 2. So equate everything to be minus 1. So in this case, X plus minus 2 times 4 equals minus 1. X minus 8 equals minus 1. X will be what? 8 minus 1, which is going to be 7. So the oxidation number of chlorine in this compound is going to be 7. 7. 10D, hydrogen in potassium hydride. So this KH, for us, you sum the oxidation number to be 0 because it's a compound. So in this case, the oxidation number of hydrogen is plus 1. Of course, X for hydrogen. So that means plus 1 plus X, which is unknown, equals 0. X therefore equals minus 1. So the oxidation number of hydrogen in this compound is minus 1. So the last but not the least, chromium in CrO4. CrO4 2 minus. To get the oxidation number of the, you equate it to minus 2. That's the sum. So in this case, let the chromium, the oxidation number of chromium be X. So X plus minus 2 being the oxygen times 4 equals minus 2. X minus 8 equals minus 2. X therefore going to be minus 2 plus 8. Therefore, X equals 6. So oxidation number of chromium in CrO4 is plus 6. So we have come to the end of today's class. Please, if you have any question, go to the comment section and drop your question. And don't forget to like, share, and subscribe to this channel so that you can always get updated when we post new videos.